Hello everyone. So this is our fifth tutorial, which is the linear static analysis of a cantilever beam with multiple load cases. And in this tutorial, you will become familiar with using load cases in a linear static analysis. And for this, we'll be using the uh, model that was created in the first tutorial, which was basically the beam. So over here, you can see I have already opened it, the model of the first tutorial. And to start with it, we'll be first of all copying the model. And to do so, right click over here and press on copy. And you can see this dialog box and we can name it as beam LC load cases. So press on OK. So you can see the copy has been created over here. And in the model tree, we'll now uh, click on the button and select this as set as root. So this is what we do so that only the contents of the beam LC model is displayed in the model tree. So first of all, to define a linear perturbation static step, we need to delete the general static step which was created in the first workshop. So we go over here and we delete this beam load static step. So yeah, okay, we press on yes so that the associated steps are deleted as well. So we press on yes and now the step has been deleted. So what we do now is we double click on steps to create a new step and we name it as beam load cases. So over here from the procedure type, we choose it as linear perturbation and keep this as static linear perturbation. Press on OK. And in the description, we can write as 6 load cases. Since we are going to apply 6 loads applied to the right end of the beam. So now we press OK. And following, we have to define a rigid body constraint to transmit the load. And to do that, we have to create a reference point which will be located at the center of the free end. So we go on to the interaction module over here, and over here we go on to the tools and datum. So over here, what we need to do is we have to select point type over here and midway between 2 points. Okay, so now we select any diagonal. So we choose this diagonal and you can see there has been a datum which has been created at the midpoint. And over here we press on this and we go to tools again and choose reference point. And now we choose this point as our reference point. And you can see RP1 is the reference point 1. So in the model tree, we double click on constraints. So to create a constraint and we select the rigid body type over here and click on continue. So over here in the edit constraint dialog box, we select on pin or nodes as the region type and click edit on the right side. So over here we edit it and in the viewport, we select the face at the free end of the beam as the pin region, which is this one basically. And now when we have selected this, we press on done. And in the reference point section of the dialog box, which is over here, what we do is we choose this point as a reference point. So you can see the reference point has been picked and we press OK and finish the dialog box. Now the next step, we have to create the loads And to do that, we double click on the load tab, and you see the create load dialog box appears. First of all, we can name the load as force X, and the step is beam load cases. In the category, we keep it as mechanical, and the type of selected step is concentrated force, and press on continue. So now we select at this the reference point and press on done, and the load will be applied. Now we have to put the value. We put the value of CF1 concentrated force 1 as 1 and keep the others as empty. Press on OK. Now what we have to do is we have to use a similar procedure to create two additional concentrated force loads, which are named as force Y and force Z, and three moment loads which are named as moment X, moment Y, and moment Z. So to do that, uh, we'll be creating the load force Y from here, and choose the point again, and for this time we put CF2 as 1. So similarly for force Z, CF3 as 1 this time. Press on OK. Now we have to create the three moments. So moment X, choose on moment. So over here CM1 is as 1. Okay. Now moment Y, continue, same point, reference point. CM2 is 1. And now finally moment Z, reference point again, and CM3 is 1. Press on OK. Now we have created three load for 6 loads, basically 3 forces and 3 moments. Now to define the load cases in the model tree, we expand the branch of the step beam load cases, which is over here and over here. What we do is, so we double click on load cases over here and create the load case. We keep the name as load LC force /X and continue. So over here we go on to the add button and choose the force X and press on OK. Likewise, we have to create 5 more load cases for the remaining 2 forces and the remaining 3 moments. So what we can do is we can copy it from over here and we can keep the name as force Y and edit this. So what we do is we delete this and we add force Y to it. Similarly, we'll do for the remaining 4 load cases. So lastly, we'll do this for moment Z. Edit, delete this, and add moment Z over here. So finally, what we do is we create a job and keep the name as job 1, and we submit the job. So the job has been submitted and we'll wait for the job to complete, and then we can view the analysis results. Since the job has been completed, we go on to the results, and over here we can plot contours of the deformed shape. And so what we do is, in order to see the results uh, individually by force X, force Y, force Z, and similarly the three moments, we can go on to the results tab, step and frame. And over here, if we choose this force X, for example, and apply, we can see the deformation due to the force X. Similarly, this is for force Y. Likewise, you can see for force Z, and similarly for the three moments as well. So this is how you can see for different cases. And right now we'll keep this as force X, for example. And so the same analysis can also be performed by using multiple perturbation steps rather than multiple load cases, which we did in this case. And so to do that, we can go back to the model tree, and over here, if we select the beam LC over here, if you can see it uh, in this one, so we can copy the model. So this dialog box appears, and we can name this as beam MS. So press on OK, and you can see a copied version is created. And now for the model beam MS, we can delete the step. We can delete the step, which we can see over here. So we delete the beam load cases step. So what we can do now is we can create 6 new linear perturbation static steps, which can be done by this linear perturbation. Step name 1 can be step fx. Continue. Okay. Similarly, we can create 5 more steps: step fy, step fz, step mx, step my, and step mz. And you can note that all of these loads and load cases will be deleted when we deleted the beam load cases step. And following, we can go on, after creating 6 steps in total, we can go on and create 6 loads similarly, similar to what we did previously. So we can create uh, a load force Y, force Z, force X, moment Y, and moment Z. And the values can be put for CF1, CF2, likewise until CM3, we can put the values as 1 like we did before, and submit create a job and submit it. And in this case, you'll see that when we used multiple perturbation steps, rather than using one perturbation step, we will still be getting similar results. And when by using both the modeling approaches, and but the only difference you'll see is that the processing time would be higher for the multiple step analysis as compared to the multiple load case analysis. So you can try following this second modeling approach as well, which is pretty similar to what we did before, but only just to recall, we'll be creating 6 steps over here. So one is step fx and 5 more steps. And similarly, we'll be creating 6 loads and creating a job and submitting it. So if you do this and compare with the first modeling approach, you'll see that the results are identical. So this takes us to the end of this tutorial.